section 6, we're talking about secants, tangents, and angle measures. So we have, first off, a theorem, and obviously the definition for a secant that we need to know. So theorem 10.12 is if two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. And then a secant is a line that intersects a circle in exactly 2 points. You'll be able to tell better in the first example, but the idea behind this is if you want to find angle 1, then you're going to take arc AB plus arc CD, because 1 is the angle that goes with these two arcs. You add those together and then half them. So it's kind of like averaging. For our first example, we're going to use intersecting chords or secants, and we're going to be able to solve for that x. So if you look right here, we're trying to figure out x degrees, what is that x? So x goes in line with 47 and 116. So the goal here is to use this theorem. So what you do is you say 47 plus 116, and then you cut that in half. So if you add 47 plus 116, you get 163. And then you do half of 163, and you get 81.5. So x equals 81.5 degrees. For example B, it's the same idea, except for if you might notice this time, see how this x is in line the opposite side of the circle. So if we were to add 55 and 75, we'd be finding this angle. So you have two options. You either do that, half it, that's this angle, this is a straight line, and then you could subtract from 180. Or if we add 55 plus 75, we get 130, meaning that the remaining two pieces would be 360 minus 130, which is 230. So these two together would be 230, and then x would be half of that. So x is half of 230. So x equals 115 degrees. And for our last example, you'll see this time, instead of the x being missing inside, it's missing on the outside. So we set this up, we just already know the answer. So we say that 128 is half of 154 plus x, because again, the rule is that you add the two on the outside, the two arcs, and you half it to get the inside. So to get rid of that 1/2, we need to multiply by 2 on each side, because that would cancel. 2 times 128 is 256. That equals 154 plus x. We'll subtract 154. And then we get x equals 102. So x equals 102 degrees will be our answer. Says if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So what that means is this angle 1 and angle 2 that are created from this tangent line matching this secant line, they meet at point A. That means that angle 1 is half of arc AB, and angle 2 is half of arc ACB. Again, remember from last week before we were on the break that third letter using ACB helps us know to go the long way around. Okay, so for this type of example, the idea is that we're going to use this rule up here. So again, the angle being half of the arc. So on A, it says to find the measure of arc JLK. So it wants to know from JL to K, this arc right here. Well, we know the angle is 116, and the angle is half of the arc. So if we want to know the whole arc, we just double this number. So the only thing you need to do is you would just take 116 times 2 and that's 232 degrees. And that is your answer. Okay, for B, it says to find the measure of angle RQS. So we want to know what this angle is right here. So what we're told is that QTS, that would be the longer arc, is 238 degrees. So if we want to know this arc, remember our full circle is 360. So we do 360 minus 238, and we get 122 degrees. Then if we want to know the angle, remember the angle is half of the arc. So we take half of 122 degrees, which is 61 degrees, which is going to be our answer for angle RQS right here, angle Q. It has a little bit more involved in it. It says if two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So a couple things to point out here. It says difference, so we know instead of adding like we were doing up here, we're going to subtract. And then for all these, they meet on the exterior. So this is talking about how they meet at A. So we have two secants, meaning they touch twice. A secant and a tangent. Secant touches twice, tangent touches once. Two tangents where they just touch once each. But you'll notice that the formula is the same. It just looks a little different from what the problem might start off with. But every time what you do is you take the larger arc minus the smaller arc, and then you cut it in half. Or maybe instead of saying larger minus smaller, you might say the outside arc minus the inside arc, and then cut it in half. The outside arc minus the inside arc, and then cut it in half. So for the first one, we are finding the measure of angle S right here. So if you notice, this is a secant tangent, so it looks more like this one. So we take the outer arc, 179, minus the inner arc, 71, and then we're going to cut that in half. So 179 minus 71 is 108, and half of 108 is 54 degrees. So angle S is 54 degrees. Okay, so for our last example, we're finding the measure of arc XZ. So that's going to help you know that 68 is that angle Y, it's not XZ. So we know the answer this time. So we say 68 is 1/2 of the outside arc, 224, minus that inside arc, XZ. So then we need to get rid of half. So we're going to do times 2. So if you double 68, you get 136. Equals 224 minus XZ. So then you could add XZ to the other side. There's just one option. Subtract 136. So then you have XZ and it's positive. So arc XZ equals, and you have 224 minus 136, and you get 88 degrees. So your answer here is 88 degrees.